So we match the number of sides, right? So that created it fine, but our values don't match. The first one is meant to be 6 and it's 4. The second one's meant to be 7 and it's 6. Next one's 4 and 5. So we're not matching the value at all. And that's because when we call that constructor, what does that constructor do? So it's this constructor with number of sides. It sets the number of sides. And part of setting the number of sides is calling the roll method, which randomly generates that number. So that doesn't work for the value. So what we can do is we can create this dice and then we can call the set value method. So let's do that. So my dice, and which one? In the array, the one at index. And we want to call set value. And we want to set it to value that came from the file. So let's run that and see if we can get those values to show up the way we expect them. And we scroll up and compare it to the file. And we have 888 and 674, 674, 53. So now the values are matching. 1212 is 4 and 9, 4, 5, 9, 10, 8, 12. So they're both matching, all 10 of them are matching, and then we come back to the default dice. So now we've been able to read from a file and create dice, create a dice, right? Create a new dice object and store it in the array. Now, when we do this, when we use an array that's big enough and likely too big, right, we can come in and change this to whatever we want, and it'll create an array that's big enough and sometimes too big. There's a couple of things. It also might be too small. So we need to be able to deal with both those cases, when it's too big and when it's too small. Let's start with the too small. So in the case that we have more than 12, right? So let's say that we have a 14 that's 3 and a 16 that's 8. And then a 20 that's 5, and a 20 that's 2, and a 20 that's 6. Now what we have is we have 15 dice, but all we have in main enough room for is 12. And we won't know that. We set up our program maybe before we even know the input file. So the user using it might enter the input file, and we won't know how big it is. So what we want to do is we want to protect from going out of bounds. This is going to read to the end of file, so it will read all 15. And whenever we fill up an array, it's our job as programmers to supervise that the array doesn't go out of bounds. Remember that the system, the compiler, nobody else is keeping track of that array and seeing when you reach the end. So as the programmer, you're responsible to make sure you stay within the bounds of that array. So the way we're going to do that is we're going to put a condition here, and it needs to be before we read. Okay, so actually it could be before we store. But a really common place to do is there's no reason to read it if you're too big. So up here what we want to do is we're going to test to see if index, because notice that index is keeping track of how many. It starts at 0 and then we increment it to 1. Now we have read 1. Then when it's 1, it goes through this loop and it fills up at index 1. And then it increments. Now we're at 2. We've read 2. So every time at the end of the loop, index has the value of how many we've read. So as long as index is less than k max size, then we're okay. So notice that this is a new condition, this index less than k-max size. And here's the condition that we had as well. When we read, it's positive. This is the condition that tells us if we've reached the end of the file or not. If we haven't, then keep reading. And this is the condition that tells us if we have filled up the array. If we haven't, then keep reading. Both of these conditions need to be true. We want to stop in the case of either one of these get false. So we need to put an and. We want to make sure that index is less than the maximum size of the array and that there's still data in the file. So we need an and there and two different conditions. And by the way, order is significant here, especially if you're reading directly into an array. So be sure and test C if you're big enough before you do a read. And that way we won't ever, so this handles the case when there's too much data. Let's run this and see what happens. And there, we ended up with dice. And if we count those, it went all the way down to where we had 12, 14, and 16. And if we look at that, 12, 14, and 16, it read all of these. And that's number 12. See it on line 12? So we read the 12 dice data that would fit in the array. What happened to the rest? We stopped the loop. This became false. And we stopped the loop. Index was equal to 12. That's not less than 12. So we stop the loop and we don't read anymore. And we've already used index 0 to 11. Once it incremented to 12, this became false and it dropped out of the loop. So that's how we handle the case that there's too much data in the file. Now let's look at the case when there's not enough data in the file. And that was the case we had before, right? Where we only had 10, and we ended up then using those, displaying those default values. And those are not the dice we wanted. We just simply created this array. They just have default values. They're not part of the game. They're not part of the ones we want to deal with. So now when we work with them, we don't want to print them out. We don't want to play with them. We don't want to count them. We only want to use the part of the array that has our dice in that came from the input file. So the other thing we need to keep track of is when we get done, how many there are. So instead of looping through the entire array, we only want to loop through the valid part of the array. Well, how do we know that? We know K max size is how big it is. That's how, right? That's the same value as my dice size. Those are both 12 at this point, and or whatever they are, right? If we change K max size, then it would be a different value, but they're still the same. My dice size and K max size are the same, but it's not the value that we want. What we want is we want 10, right? And so how are we going to tell that? Well, it turns out index is keeping track of that for us. When it starts, it's 0, and that's how many we have read. And then we read 1 and store it. Now we're at 1. That's how many are valid. We do another loop. We read another value stored in the array, and we increment index. Now it's 2, and now we've got 2 in there. And if we keep going, then index has this value. And when it stops, so when we read that number 10, index is 9. We read in that 10th value, we store it at index 9. Remember, index 9 is the 10th location in the array, and we increment index to 10. And now we go up there and 10 is less than 12, but we try a read and we're all done. There's no more data. So there's no more data and we have not filled up the array. Well, index will have the value we need. So now if we, instead of going to size, we simply go to index. Let's see what happens. And now we read it, and how many do we display? We end up displaying all the ones that we read, all the way down to 12 sides with a value of 9. If we look at dice, that's our last value, 12 sides with a value of 9. And we read it and stored it in the array. And now when we worked with the array, we're only working with the valid elements because we changed how we're looping through it. So we're not looping through the entire array. We're only looping through the valid elements in the array. So that's how we manage when we have less data than the size of the array. So either way, we can read data from a file, protect the array from going out of bounds. When there's too much data, use the index value, the one we've kept track of as we've been reading the data, to identify how many valid elements there are in the array.